Coding. So basically, I so I believe James talked about uh Ohm's law through V equals IR, correct? Did James talk V equals IR with you, or wait, you did it, James? Okay. I Wait, then what did you teach them yesterday, James? So you taught. Okay, so this is getting a little confusing. So I'm just going to explain what, in my terms, what V equals IR it means. So V equals IR, I don't know if James actually taught you this. Current times resistance. So in terms of what everyone can see my screen though, right? Or yeah. So V equals IR. So basically, voltage is equal to current times resistance. In the case that voltage is equal to I times R. So, and how this, I'm assuming James taught you like the RC circuits. So like the key to like voltage equals IR is the application of it. So V equals IR. I is equal to V over R, or you can turn it as R is equal to V divided by I. Voltage over I. There's many ways to do this, but these three different formats, you just need to derive it from V equals IR, and this is what people call Ohm's law. Ohm's law. This is the one formula they call it. This is like the one formula they call it as. You can change it to these different arrangements if you're interested into doing it. If you're interested in doing it, you could do V equals IR. So like how this applies to the circuit, because I'm pretty sure James probably went over this, but I'm not sure how he did it. So if this is a battery, and so a battery, I'm pretty sure James touched this. This is a negative side. This is the positive side. The positive side is always the longer side, and then that's how you can differentiate it. Do not believe a battery is this. This is not a battery. There's something completely. Do not believe a battery is just two straight lines. That's something else completely. That's a capacitor. We're not gonna go into that though. This is I'm gonna draw a simple circuit and say we have a resistor here. Resistors always look like a jagged line, and this is supposed to be a resistor. So this is going to be a resistor, and the key to this is that, okay, so say this resistor is, we know that this resistor is supposed to be what? Say that this resistor is supposed to be equal to like 20 ohms. Everything is measured in ohms for resistance. That's how I've described it up there, current times resistance. So the key to knowing this is that, say if we give this battery a 9 volt, let's say a 9 volt, like just to go with it, the voltage of the battery, like if you see any like DC battery these days, everything's in DC by the way, but like any like battery you see these in modern day is going to be in DC, and it's always going to be in voltage by voltage measurements. And then if you see this voltage, you have to understand that positive always goes to negative. So if you see the circuit, it may seem pointless to visualize this, but it goes from here to here. This is very important to visualize later on, and it's something I recommend. It's something I recommend. Okay, I'm recording. I think I didn't record. So basically, we're going through this. We're going through this circuit like this, and this resistor is 20 ohms. This is 9 volts. So if you just derive it from I is equal to V over R, you can pretty much tell that V is equal to IR. So then that means that if you flip the equation, then you would get that the current is equal to V over R, which I've already explained. And then V over R, the key to understanding this is delta R. So this is technically delta V. So basically you have to find all the batteries in the circuit, because there's something called Kirchhoff's law. This is something to also understand, Kirchhoff's law, which means that the entire circuit ends up at 0 volts. Ends up at 0 volts when the circuit is over. When the circuit has gone through. This basically means that this resistor, what basically means is that if you look at, I'm going to move this, so basically this is very important concept. It is very important later on and extremely important in Division C. What Kirchhoff's law basically means is that in this case of one loop, you see this one loop, in this case of one loop, it basically means that these 9 volts turn up to 0 when it finally reaches up the battery, as anything inside the circuit takes away that volts. So you know the resistor of 20 ohms in this case is actually taking 9 volts. This is taking 9 volts, and that is directly why you can, and that is pretty much how you can like know this. That's pretty much how this formula works most of the time. Someone's joining. Okay, and then that's pretty much how you know this works most of the time, because this is a very important concept to relate. That could mean that the entire circuit ends up at 0 volts, which means that whatever goes on in the circuit is consuming what the battery has. Now, there might be multiple batteries in the circuit, but we won't get there yet. But in this case, because it's one battery, the entire circuit will take that voltage in the battery. And the V over delta R is because in series, I'm pretty sure James probably taught you this, that resistors probably always go. The resistors probably always go in series. So resistors, I mean not always in series, but resistors when they are in series, they usually say this is 9 ohms, and this is 10 ohms. That's the ohm symbol, by the way. This brace is what the ohm symbol is. But if you add 9, if they're in series, you probably already know that it's 19 ohms. I'm pretty sure James must have taught you this or something. It's 19 ohms, and that's a key part to knowing the circuit. And with that 19 ohms, all you're doing for the current is V over R, which is just the voltage. In our current case, voltage is 9 over 19 ohms, because this is the, because let's say this was a, let's just add for visual sake, I'm just going to add that part. But say we have another part that is 19 ohms. That you add these two up because they're in series. In series, this is what you call it when resistors are in series. They pretty much look somewhat like this, and they're basically just lined up. If you visualize this as kind of like a line where you like cut off part of this, it'll pretty much all end up like a line, and it pretty much is 9 over 19, which is equal to and with 9 over 19 amps. 9 over 19 amps. Now you can do the math later, but that's not the key point. It's measured in amps. Now what amps represents, and I'll get to on later, which is a very important concept to understand, is that amps, I, is actually equal to coulombs per second. Coulombs per second. This is a very important concept to reach, and it is very important because many tests will actually focus on this concept that many people do not understand. Current is a measurement. Oh my god, how many people say that? Current is basically a measurement of coulomb second. Coulomb itself is a measurement of how many it's like basically a measurement of like charge, and basically like electrons, right? How does, like in an atom there's like electrons and protons. These things have like positive and negative charge, and basically the positive and negative charge you see, there's like a specific way to measure just how like the charge of them, and then that's measured as coulombs. So basically what happens in a current is that you see there's actually electrons moving through it. That's the key point. There's electrons moving through in a current, and that's why it's coulomb per second, because electrons actually have a value. Electrons actually have a value in what they are. electrons actually have a value in what they are as they go through the circuit. I do not remember this perfect value because it is so basically it's a very small number because Coulomb is actually quite big, times 10 to the power of negative 19. This is something to keep in mind. This is what one electron is worth. One electron. I'm not going to say that. I'm not going to draw the right electron, but you get the point. One electron is equal to 1.6 times 10 to the power of negative 19 coulomb. Coulomb is a measurement of the charge of this one electron. And what happens in a current, to understand the current, is that you actually have you have multiple electrons and going through the circuit, and that is why the coulomb, you see the coulomb here and then the coulomb here, that's why it's coulomb per second. Basically, it's about number of electrons per second. You can derive how many electrons there are by knowing coulomb. You can just like reverse the formula, but you basically get the point here. Wait, does anyone have any questions? Because no one seems to be talking at all. Do you guys have any questions so far? No one? There's like 15 people here. No one? Okay, I guess everyone is understanding this. Oh, I'm too good of a teacher. So, probably not that though. So basically what we have here is that 1.6 times 10 to the power of negative 19 coulombs. And this is very important to understand what a circuit is. So if we go back to this circuit, as I'm stating here, it's the reason why I divert to understand what current is, to understand what resistance is, because all of this is interconnected, and that's what I want to get to the key of Circuit Lab, is that everything is interconnected, and you don't need to use one method. You can use a different method, and you can probably get the same result. Maybe slower, but same result. So if you go back to this circuit, I've explained V equals I over R, and because V equals I over R, I've also explained that R is equal to V over I. That's a derived from the formula. But what you can basically see, as I've explained here, is that look, if we oh wait, I actually visually did something wrong here. It's supposed to be 10 ohms, but it's supposed to be 10 ohms. I visually did something wrong here. It's supposed to be 10 ohms, but what happens here is that these 10 ohms and 9 ohms, this as a total resistor, because you can just add them up. You can think of them as basically like one big resistor. You can think of like basically this as one like big resistor. You can just think of this as one big resistor, and you would in series, you can think of like all these resistors lined up as one big resistor. And if you think of them as one big resistor, you can think of that like, oh, this big resistor, it only has 9 volts going through it, which means that if you do V over I, you just get the resistor of 20 ohms. So you probably can derive all of this, and I think James probably went over this, which is probably why I could do your homework, but I'm just deriving this. I'm just like trying to like go into detail, because the key part in Circuit Lab is that in many of these questions, they ask for, many of these questions, it comes down to understanding to do the harder question. To do harder questions, and that's pretty much all of the events. You need to have like a great understanding, all invitationals. Not the regionals, but all invitationals. It's very important to understand this. I'll just like zoom in probably, because you probably might be not able to see that. But that's a key part, understanding to do harder questions. It comes down to it's all in the all invitationals. So because you've pretty much understood what you've pretty much gotten to, I'm pretty sure everyone is like pretty okay with like how you do like pretty much all of this. So if I delete that then, because I need to draw another circuit to the left. So if I draw another circuit, and let's say in this case it's going to be let's say I draw negative. I'm gonna always label this, but in proctors will not label this on a test. You will need to figure this out yourself. So say I have 2 batteries here. The key part is that if you look at these batteries are in series right now. If you look at these batteries are in series, because the negative is lined up with the positive, and the positive is lined up with the negative. However, if for example, that this, instead of having like a long and short, these are in series. But unlike resistors, they actually have a direction. Resistors do not have a direction, so you don't need to worry about it. but batteries do have a direction. That's the key part to understand. They have a direction. So if it was like this, and it's like a short end on this side, and this is negative and positive on this end, you need to understand that these batteries subtract their voltage. To find the total voltage of the circuit, when I mentioned delta V, you need to figure out that these batteries actually subtract from each other because there's direction in the circuit, and that's what happens here. And that's a key part to understanding. So like say this was like 9 volts, and this was 5 volts. You can choose which, the circuit will go whichever direction, whichever battery is greater, it will go in the direction of that battery basically. It will, if this is 5 volts, it will, because it overpowers it, it's just 9 minus 5, which is equivalent to 4 volts. But that's not like the key. Well, that is the key point. But like 4 volts, it's going to go in this direction of like the battery that's greater. And that's one understanding point that I don't know if James explained. But James says he did something. I don't know. But let's just go back to the one battery example because I don't want to complicate things too much. Say I have a line to represent a battery here, and I have a negative here, and say I have a circuit here. I'm pretty sure James must have explained this, or else we have a disconnect here. But I need to explain to you methods to do this question faster, and the understanding behind that method. Because this, I don't know, there are a couple formulas to do this. So say I have 2 resistors in parallel with each other. Parallel just looks like this. You pretty much know that there's this, if I get my yellow highlighter, you pretty much know that this is going to be one chunk of the parallel. It's very nice, think of like this, and this is another chunk of parallel. What a great way to see this is that what the equivalent of this would be the equivalent of like this resistor part, because it's now parallel. The equivalent of this part, that would be equal to 1 over R total, the resistance total, RT, is equal to 1 over R1 plus 1 over R2. Well, you can continue this on and on forever, dot, dot, dot. But like the key point to understand is that R1 and R2, that is basically how to find it. So like if you say I have like 9 ohms here, and this is like 10 ohms, because it does, if you want to, there's a trick to solve only 2 of them, but that trick it's not really needed. So let's just go to like basics. So what the key to do here is that what it would actually be is that you would be doing 1 divided by 1 over 10 plus 1 over 9. And that is what you would be doing. Do any of you guys know the answer to this? Because it's actually important to solve this. You guys can talk, you know that, right? I believe that if you talk in a class, it's a lot better because it would solve everything, but sure. If no one wants to talk, the answer is 4.73 then, because I have a calculator out. 4.73 ohms. That is the conventional way. And say this is like 10 volts. You say this is 10 volts with the Ohm's law, because I is equal to V over R and R is equal to V times R. You pretty much understand exactly how to solve this. Now, how does this derive into how you know the current between these resistors? Because the current here, it actually splits up in this case. It splits up. Now, it's actually a way to think about this is that current likes to go into the bigger current. A good way to think about this is that bigger current goes to smaller resistor. So this is always a nice thing to think about. Bigger current always goes to smaller resistor. There's 2 ways why. I'll explain like the easier way to comprehend is that it's just a fact you need to understand. I'll explain to you why after we understand this, but big current goes to smaller resistor. So it's actually an inverse. The key part is that it's actually an inverse ratio between the 2 resistors to find current. So it's actually an inverse ratio. So you have to ratio this. So it would actually be that 9, so that the I, so that I, the 10 ohm, the 10 ohm I would be equivalent to 9 divided by 9 plus 10. 9 plus 10 because as explained, the bigger current always goes to the smaller resistor, which means its inverse ratio. It will be a 9 divided by 9 plus 10. And in the case of the 9 ohm I, it would be as 10 divided by 9 plus 10. It's an inverse ratio in this case. Now, the key to understand here is that the current splits up, but you need to understand direction. Oh, actually, I flipped the direction of this. I accidentally flipped the direction of my battery. This might have confused you guys, I'm sorry. But the positive, you need to understand the direction of this and how it splits up in parallel. Now, a key factor to understand that you may not know is that these two resistors share the same voltage. That is the specialty of a parallel circuit. They share the same voltage. All resistors in parallel share the same voltage. This is a key thing to understand, and I don't know if you guys I've seen this or not, but all resistors in parallel share the same voltage. This is a key thing to key concept to understand, and you can do tricks of this, and this is exactly what I want to get to here. But do any of you guys know what can be done with this circuit because you know that all resistors in parallel share the same voltage? Anyone? Anyone? Does anyone know?
Amount of power.
Can you repeat what you said? The microphone wasn't that clear.
Oh, okay. Can't the lights in a parallel circuit have the same brightness due to sharing the same voltage?
Yes, but yes, that is true. That is one thing we can realize because lights, incandescent light bulbs usually in a circuit do have a resistance in them. But how can you use the VO equals IR in the case of all resistors in parallel share the same voltage? How would you do this? There's a very simple trick. I'm just trying to, because if I'm just telling you everything, I know that you guys will probably forget all these concepts, and I know that's probably not what a good teacher should do. Oh well, no one's answering. Okay, so the key part in this is that all resistors in parallel share the same voltage. Now, because there's 10 volts going directly into here, because there's 10 volts going directly into this circuit, because there's no resistor, there's no resistor here, there's no resistor here, there's no resistor here. If there was a resistor anywhere else in the circuit, it would not be 10 volts. You would have to subtract 10 volts minus the 10 volts minus the other voltages. Say this is R1, this is R2. Oh, my bad drawing skills. R2. This is R3. We don't need to know. We already, let's give them values though. R3 and this is R4. We can state that equals minus R1 minus R2. If there were other series resistors, you would know the voltage that goes onto here. But that's not the case. This time, we do not have minus R1 minus R2. This is just a hypothetical situation. It's just to tell you that this trick is in special circumstances and you should not apply it to everything. But if the circuit is like this, you know that actually 10 volts is going to each of these resistors. So actually there's 10 volt. If I need to I'll include a text box because I don't think it's actually 10 volt. Oops. It's actually 10 volts. 10 volts on each resistor. This is the key point. The resistor, the voltage that goes in, the equivalent voltage of the entire parallel circuit, is equal to the voltage on each resistor. Now, can anyone figure it out after I've told this much? I've told this much. All resistors in parallel share the same voltage, and the equivalent voltage of the entire parallel circuit is equal to the voltage on each resistor. Do any of you guys know at this point? Anyone?
Is it because the voltage is is it because the voltage is over the amount that the battery is giving like naturally does the battery give more voltage so it
No,
can
no, 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 no. Like no. That is a misconcept. We need to understand. No, that's not it. We need to understand this very important concept. I don't know how much this. If anything in circuit lab, this is the most important concept you should get. Kirchhoff's law. That the entire circuit ends up at 0 volts. Nothing is created. It's just ending up at 0. Nothing is created. It's only lost inside the circuit. You need to understand this. This concept is extremely important, and it is very important to memorize. You cannot add voltage, or you could add voltage out of the circuit, but the total battery, the circuit ends up at 0 volts. If you got the voltages of everything, because these resistors are truly negative volts, because they're actually taking away volts from the battery. But if you said the resistors were like negative volts and you added all the batteries together, it would always end up at 0. It is a key point I want to emphasize, because to get into advanced circuits, it is the only way to do that is to memorize Kirchhoff's law. What the true way to do this is that we're applying this very good formula. Voltage equals to IR. You can use that on each of these resistors. You can use it on each of the resistors. That is the key point. V is equal to I.
I think we should do some practice problems now. We only have like 20 minutes.
Yeah. Do you guys have? Nah, it's fine. We don't need to. I use a different method. I can just give them practice problems like in the last 5 minutes and say do that as homework. V equals IR. So then that means that to understand the circuit correctly is that R is equal to V over I. That is something to understand, which means you can derive the current as I is equal to V over R. This is a key concept I want you to understand. These three things are interconnected, and you need to understand this. All resistors in parallel share the same voltage, and it only shares the same voltage once you subtracted my R1 minus R2 hypothetical. This is just hypothetical. You need to subtract all the other resistors. After you subtract all the other voltages, and you're left with the voltage of the equivalent voltage of the parallel circuit, you need to understand that current equals V over R, and that is for each of these things. That is why when you have when your R is lower, your voltage is the same. That means the current is higher. If you look at this circuit, that's why when R is lower, current goes higher, and that is exactly why this concept that is exactly why I said big current goes to smaller resistor. This is how everything is interconnected, and this is exactly what the point I've been trying to make. I took the V over R, and this is exactly the concept you should understand. This is a basic concept to grasp in parallel circuits. Does everyone understand this? You can type in the chat if you don't want to talk. Okay. Seems like everyone understands this. Did you guys learn this yesterday? I'm just making sure I'm not over teaching, so because I don't wanna like. Wait, what is it? Okay, whatever. I'm going to take a screenshot of this. Don't be alarmed by the screenshot that I saved. It's just because I'm gonna keep this as a screenshot in case anyone wants to review this on their own time. There's no need to post the screenshot after it's just for my own purposes. So I've explained, I'm focusing on current today. I don't know why, just feel like it. Coulomb per second. I've explained this earlier. This is a concept to grasp, and I've told you that each electron, one electron, I don't want to write electron because that's going to be too frustrating, is equal to 1.6 times 10 to the power of negative 19 coulomb. Mind my bad handwriting. And what this means is that, so how do these electrons work together? Well, we have a specific law for that. So let's call these two charges. They can be protons, electrons, well, I'm gonna label them. There's gonna be two charges. We'll call them positive charges. So charges is basically just a reference to like what these particles are. They're just like positive charge, negative charge. Either measured in coulomb for how much the charge they carry, like how big the charge is. And it doesn't really, you can just call this positive and negative. I don't really see the point of like, you don't need to label them the electron. You just need to know the electrons are what go through the circuit. And then you have these two electrons. Now, there's also something that goes in between this. I don't know if you guys learned previous physics, you might be familiar. So there's actually a force that happens because let me explain something, divert a little. You guys all know positive attract to negative. In any case, positive attract to negative, and then they go together. And then positives go away from it, right? Positives don't like each other, and the negatives don't like each other. And this is exactly what you need to understand for these two charges. These two charges, you need to understand that if this was, say, negative, if this were negative, then the force would actually be going this way, and the force would go this way, because force is a vector. Force is a vector. I think you guys, force is vector. And I'm just gonna use text box. I don't really want to write everything by hand. Force is equal to vector. Can you guys all see this? All see the words on the screen? Okay, sure. So because force equal to vector, because we have all this force equals to vector, I don't need to waste more time on this. Force equal to vector, then you need to understand that the force would be going this way, force equal that way. So to go back to, So to go back to the positive example I put here, that means they attract to each other. Now, there's a new law I haven't explained yet, but it's perfectly fine. So there's actually a force, and you must have thought, oh, if these are farther together, won't the attraction force be less? And that is exactly true. So let's label this D for distance, and then these have a charge. Charge is always measured in coulombs. I'm telling you this right now. Charge is measured in coulombs. And then the key formula to understand is, oh man, this is I couldn't Control C, Control V this right. So let's call this Q1 charge and a Q2 charge. Okay? This would be Q1 times Q2. I'm gonna like Q2. I don't know if I'm sorry for pardon my bad writing, but I'm using a mouse. Q1, Q2 over D squared. I'm sorry for my 2 that looks like a 3. Okay. Q1, Q2, and this is times K, is equal to force. Now, I've already explained the units here. Q1 is a coulomb. It's measured in coulombs. How much that charge is measured in coulombs. Oh, this is absolute value. I'm going to put this absolute value simple. It doesn't make it, it doesn't matter if they're positive or negative, because it's just going to be the force going this, if it's positive or negative, it's just going to be the force going the other way, the force going attraction. They would be the same. They would just be the same in this case, and they would just be the same. So that's why you can add the absolute value sign if you're that interested. Force is equal to K times Q1 times Q2 over D squared. D squared, if you've done for anything of force, is supposed to be in meters. And then Q1, I've already explained, it's measured in coulombs. If you guys want to know how to spell coulombs, because I don't even think I mentioned that the entire time. Coulombs is spelled like this, okay? Coulombs is spelled like this. Coulomb is spelled like this, if you're that interested. But that's basically it. So now if I go back to the formula I've done here, Q1 times Q2 D equals meters. The key part to understand from this is that this is just force. K is a constant. It's just a constant you always need to apply that basically transfers all this information you see here into a force. So basically K is equal to us, it's not, okay, so it's 8.987 times 10 to the power of 9. You need to memorize this K unit, And most of the time, if not always, it's rounded up. It's rounded up to 9 times 10 to the power of 9. But this is the true format. I'm just being honest to the true format. There's more to this number, but this is the more to this number, but like you can see this is not 10 to the power of 7. Why did I write that? 10 to the power of 9. 10 to the power of 9. And this is just something you need to care about, because coulomb in these charges is actually extremely small. It seems big, but it's actually quite a small margin. These charges carry very little charge, and that's something you need to recognize. That's why when you look at one electron, it's not a lot they're carrying. In fact, they're carrying only this little coulombs, which is why this K is so big for most of the part. That's something to think about. And then in this case of K equals coulombs, let's say I give a Q1, I give a D is equal to, in this case, I'm just gonna like make you guys do the math because I just want to see if you guys understand this formula. Equals to 10 coulombs. This is extremely big. Do not think this is what you're going to get at comp. They're going to give you really small numbers. Can you solve this? If Q1 is equal to 2 coulombs, D is equal to 2, Q2 is equal to 10 coulombs, and I give you the formula 8.987 times 10 to the power of 9 is equal to K. You can just make it 9 times 10 to the power of 9. Can you guys find the answer? You can find the answer. If you don't want to talk, you can just type in the chat. Did you get an answer? I want to make sure everyone's following along because this is pretty basic math last time I checked. Do you guys know the answer?
Can you put it back to the whiteboard for a minute?
Yeah. Oh, I don't think this is a minus. Do not think of this as a minus. I'll erase this. This is just to refer that this is coulombs and that this is in meters. D is in meters. D is in meters. It's supposed to be meters squared. It's meters. It's supposed to be meters squared. But that was just a reference to the units in that case. This is the exact way to the alignment absolute value. I'm pretty sure all of you guys will learn absolute value because the score math is pretty bad. But you can understand that it's just because direction matters. But in the case of coulombs, you're looking at the magnitude, not like if it's positive or negative. Because coulombs is positive or negative because there's different charges. Like a negative charge, you have a negative coulomb, and a positive charge, you have a positive coulomb. That's the key. I hope I'm not going too fast. I have to have more active students. Like I have a class of 3 students and they're a little bit more active. Okay, so is what 3K? Actually I'm just gonna do this math really fast. I gave you guys really big numbers and I don't think I should have because I got 4.5 to the power of 10. Because I state that K is equal to 9 times 10 to the power of 9, and that is only getting divided by 2 squared. You're multiplying this by 10, multiplying this by 2. So if I were to write this formula, because F, does anyone actually want to take a try at it? Besides, you were close, you're half close I guess, I don't know how to say that. F is equal to 9 times 10 to the power of 9. I'll just use 9. Most competitions will use this. In most competitions will use 9 times 10 to the power of 9. Sometimes they use 8.9, but I doubt they would. Let's just say the multiplication symbol times Q1, which is 2. It's supposed to be positive 2, and this one is supposed to be times negative 10. It's kind of useful to know this, but I wouldn't. It's measuring magnitude in this case. Force measures magnitude. It's not really important that this is positive or negative. It's a vector, but like, it's measuring magnitude. And d squared is 2. If you were to do the math, you would get like a big number because you're just doing 9 times 10. It's just, if you can just do this math in your head. It's just, this would be equal to, this part would be equal to 20. And this part would be equal to 4. So this would just be 5, 9 times 5. 9 times 5 times 10 to the power of 9. And if you leave answers in sig figs, I mean not sig figs, if you leave answers in exponential form, it's equal to 4.5 times 10 to the power of 10. And that's what my calculator says. So that is how you do the formula. You guys understand my previous explanation on the circuits, correct? Anyone? There's even a Sheik here, and he's going to 9th grade. Do you guys understand this? Type in the chat if you don't want to talk. Okay, everyone seems to understand this then. Okay. So if everyone seems to understand this at this point, we're gonna go into more, this will never, okay. Do you guys want to okay, so, I'm pretty sure you guys have always wondered, what if it's more than 2? Some competitions will test this, so I'm going to zoom out of this, take a screenshot just for screenshot, and I'm just going to Control A and delete everything. Now, because I've explained this column for, you need to, okay, I should have not deleted that. It's very important to understand this constant, right? I'm gonna do this in so you can always see this. It's very important to memorize this and this. These two will be very important formulas, and as previously explained, Kirchhoff's law is very important. It is the basics of Kirchhoff's law and Ohm's law. I don't know if you guys can see this because Google Meet has the weirdest processing ever, but Kirchhoff's law, and then K equals this, and then you also need to know this. I can't zoom. Oh, I have to do something else. Activate pen. Okay, and then this. Okay, you see this? This is what's important. Okay, so yes, so basically that's the key concepts, and now I'm just gonna delete this just for you guys to understand. So now it's time for some testing phase, I guess. So I've previously said we have 2. Now what if there's 3? What if I have a positive here, a negative here? Now in the case there's 3, the thing you need to understand in the case there's 3 is that you need to understand the vectors. You need to understand the vector here, because what's gonna happen if there's 3 is that you're not measuring. Okay, when there's only two, the force on each of them is going to be the same. The force on each of them will be the same. But when there's 3, all forces will be different. On the forces, it's not always different, but it should be taken to a consideration that they'll be different. So what should be understood from this is that the questions are only asked one of the columns, one of these charges. That's the key. Now, if you look at this, you're like, wait, there's an attraction here, and then there's a repellent force coming from here. There's a repellent force that comes from here. I can say the attraction here. That you can draw all of them, but you're only focusing on one. I'm focusing on this one for now, okay? I don't want to draw on that. I'm gonna use rainbow color because it seems like everyone can see better if I use rainbow color. So this is the key part. Now, I think most of you guys have probably seen what's coming now. You just subtract these two forces. All you do is that you calculate the force that first comes from here, and then you calculate what happens between these two, the distance between these two, and the columns between these two, and the distance between these two and the columns between these two. And whichever one's greater, you just subtract f greater minus f less. And that's the key. Do you guys understand what I was trying to say or not? Because if you guys understand this, I do not see the point in going. I do not see the point in looking at this deeper. Message? Anyone's gonna message? Okay. If you've understood this, because I'm pretty sure this is a very simple derived formula. They will not do any more geometric shapes. They will not go into 2D geometric shapes, because if it's 2D geometric shapes, you need to know trigonometry, and I'm pretty sure this is the most I've ever seen a competition go to, and that was last year. So basically, now I want to review. Now I want to review because you guys we only have 16 minutes left, and this is everything I'm supposed to talk about. So I'm pretty proud I finished everything, I guess. So let's say I have a positive and a negative. Oh, I had slides. Was I supposed to use that today? Okay, so positive. I'll share the slides if any of you guys want it, but I'm a guy who just likes to do impromptu because I believe that's the best way to do an assignment. It's what all the good teachers in my life have done. So I'm gonna do this in red this time because why not? And I'm going to do this in I'm gonna do like a triple. I'm gonna do a triple. You guys should know that each of these you guys should know by now that each of these pathways are different parallel parts. Each of these pathways are different parallel parts. So if I added a resistor here, you guys should know that this resistor, is actually, I'll separate the parts for you guys so you guys can easily tell. This would be like one part of the parallel, this is another part of the parallel, and then this would be the last part of the parallel. This is a great way to understand it. This is a very nice way to understand it. And I'm just helping simplify this for you guys because you guys may not be able to identify it yet, but over time you'll be able to. And I'm just gonna see if you guys have understood my previous concepts because my previous concept makes this very easy question. In fact, this is the most frequently done thing on Circuit Lab, and you should probably understand this at this rate. So I haven't gone to capacitors yet, but I'm pretty sure capacitors is a build-up on Kirchhoff's law actually, which is why I'm telling you guys understand this. 10 ohms, 5 ohms, 2 ohms. Okay, ohms are usually in K because ohm is actually a very small number. I don't know if I don't think I told you this guys yet, but ohm is equal to a constant length over area. Length over area, it just represents this is just the permittivity constant. It's just the constant based on the material to find the resistance. And this is the length of the material over like a sectional area. So say if I have like a square part, say I got this like square part. Don't blame on my bad drawing skills, but like say I have this rectangle thing. This is just like this right here, which you see here, is just the constant based on material. You will probably have this inside your binder. You need to have like a couple things. You need to have different resistor color codes because resistors usually have color codes to figure out the resistance on them. That thing should just be in your binder. And you should also have this constant. Sometimes just because. And it's just length. Like this represents the length, like this section, and the area is just this. It's just this one little cross sectional area. So this is just one cross section area times the length. Or like in the case of a sphere, I'm so bad I can't even draw a sphere. But if say in the case of a sphere, you get the point, I guess. You get the point. But that's just another thing to understand. This is only important in some cases. But now I want you guys to solve this. I want you guys to solve this circuit because I'm pretty interested in seeing the results. And voila. I already explained to you the different chunks of them. So each of this, so that means that voltage remaining for the equivalent voltage for the parallel circuit would be on each of these chunks. It's supposed to be not each resistor, each of these chunks in this case, each of these chunks. And you're supposed to treat them as if they're series. When they're in these like parallel parts, you're supposed to treat these like series inside these chunks. So can you guys tell me the answer? Because I've given you guys all the information necessary. It will probably take a couple minutes to solve this. If you have any questions, just ask. Anyone? I'm literally like having this entire tab open so I can see for messages. Anyone? 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 Actually, I did not even ask a question. Okay, I want to know the current. Say this is I1. I want to know I1 here. I want to know the current I2 here. I'm giving you the direction of the current. I know. Okay, so another thing to understand is that if the direction of the current is not what the question says it is, the current is probably negative. But in true cases, the current is always positive. Because if they ask for a current going this way, and this current is not even like logically possible, it's just the negative because of the opposite direction. But like that's not the key point. I'm just trying to give you guys different concepts. I1, I2, and I3. I want to know these different currents going through them. I1, I2, and I3. These are the currents I want. You can also give me I4 here. That would be one. That would show me that you guys have been paying attention to this, and I've told you how to do it. It's a delta R. So you're finding the equivalent resistance of this plus the equivalent, because once you find equivalent resistance of this parallel part, you can treat the equivalent resistance as a resistor that is in series with this 10 ohms. And then you can just add them together, basically. And then that's it. And then you guys can tell me the answer. Yeah. This is one of the most common questions you've probably faced. And if you guys can understand this, you're set for one question in comp. Couple questions in comp. Oh, there's also hand-on. I'm going to probably explain the hand-on using a video. But it's probably going to not be the best, though. You guys know the answer, or do you guys have any questions? Do you guys have an answer? I'm paying attention to you guys because I can see when you guys have done something on here. 30? It won't take me long to. There's only. Eric Chung, do you mean that which one? There's I4, I1, and I2 and I3. Which one do you mean by is it 30? Cause.
Like all together.
Oh, 30 ohms. Is that what you mean, Eric?
Yeah.
Let me just check this passively. Actually, I'm pretty sure you're right, but I'm pretty sure you're right because there's a couple ways to figure. There's a couple ways in my head to figure out if your answer is makes sense basically. There's a specific way that all these resistors work, so that if you tried, all of them would that trick would be like way too like it's not yet ready for us yet, but I got 12.3. There seems to be something wrong with the math. Because the only way to find the equivalent resistance of this circuit is to go with the old-fashioned 1 over R1, forgive my hand drawing skills, plus 1 over R2, plus 1 over R3. And that is the key to understand this. You ask if, oh, no. Soham, the key to understand here is that this voltage is only over delta R. This is only over voltage is equal to, I is equal to V over delta R. Delta basically means total R. You need to know the total R. So you need to add this 10 ohm with the entire parallel circuit here. The entire parallel circuit here. It's the entire equivalent parallel circuit here. The equivalent resistance of the circuit plus this 10 ohms would be 9 volts over that. I've given you guys the formula to plug in pretty much. Yeah. This is to hunt your true understanding, because once you get your understanding, many of these explanation questions they ask are like easy questions to you. And another way to, if you guys really want the form, this I4 would be equal to 10 ohms, not 10 ohms, 9 volts divided by 10 plus equivalent resistance, REQ. REQ would represent the equivalent resistance, okay? REQ represents the equivalent resistance, and that is something that you guys will have to find. Yeah. I bet most of you guys in physics events will go to machines. Machines probably didn't get the recording yesterday, but I promise you I have my recording, okay? I promise you that. I can promise you that my recording is on right now. Yeah. So you guys need to understand this. If you guys don't understand this, you probably have your dads and moms with engineers to probably help you. But like, do you guys understand this? Can you guys solve this though? I want to know I4 at least. If you guys I4, I know you guys are on the right track at least. Oh, can I unmute people? Oh man. Oh, close, not. Wait, that's actually it though. I'm pretty sure that's it though. That's kind of close. It's supposed to be. I got 0.4. Yeah, I got 0.4 because if you find what R equals is equal to, I've told you what I'm just gonna what happens here is that I'm just gonna erase these R values because it's 10 times easier to just go over my old work. Because if you just treat this as series, you've got 5 here, you've got 9 here, because I told you 7 right here, 2 right here, 9, then 8. You solve this. This is actually a pretty good number of 12.3. It rounds up to this. So this is just R equals is just 12.3. And then if you get that, that's around 0.4. Around very close to, actually it's very close to 0.4. And they usually tell you what to round it to. If they don't tell you to round it to, do not use significant figures because those suck in circular. Those suck like heck. So just ask the proctors most likely. And then for these other, can you tell me R1, R2, and R3 now? Because to find the voltage on this one resistor, all you have to do is multiply the current that's going through it right now, I4, times the 10 ohms. Just as I've explained, V equals to IR. This is just I times R. This is just I times R. Don't think of this. This is just I times R. See this. I times R. Oh my god, my drawings are so bad. I times R. So can you guys tell me? Because now I know that. So what is the voltage of this? You know what the voltage of the resistor is. So you can just subtract that from the battery to find the equivalent voltage of this parallel circuit. So can you tell me that? I want to end the meeting with a nice explanation on how to solve something like this. Guys, I've got I have 12, 11 other people, 10 other people besides the ones who's on the chat. I hope everyone's, I believe everyone's solving this because first times, this might take a long time. People probably have another meeting to go to, so I wanted to end this here, but do any of you guys see the answer? Anyone? Anyone, man? Anyone? Because this will not help anyone if you guys don't solve yourselves. I've experienced this before too. Someone lecturing will not help you as if you don't take the opportunity to solve. No one? Wait, is everyone just taking notes? Everyone is taking notes right now, right? They're not just like being AFK and then putting their screen here to show their parents that they're doing the work. Okay, I guess most people probably need a little bit more help. So I4 times 10. I've just explained that I4 is equal to 0.4. So if you plug in the answer here, the voltage on 10 ohms. Sorry, my 4 is a little bit off. 4 times 10 ohms. You would get V is equal to 4 volts. This is actually a pretty good answer. I did not expect this, but that just means there's 4 volts on this 10 ohms. Now if you subtract 9 volts minus 4 volts, that would be the equivalent voltage. 5 volts would be the equivalent voltage of this. And I'm going to use yellow highlighter. Please tell me if your screen can see this, because I can barely see it if my brightness that high. So this yellow would be representing it. If anything, I think this might be a better addition to it. Okay, so so this would be equal to that 5 volts I've explained. Now, with that 5 volts, everyone should have recognized this by now, that what each of these resistor big chunks, I'm just going to call them big chunks for now, because they don't really have a formal name. So let's call these big chunks. That means that each of those big chunks, they have a voltage of 5 volts. 5 volts, and which means each of these big chunks. So let's call this chunk 1. I can't do that. Let's call this chunk 1 for big chunk 1. Big chunk. This is big chunk 2. Big chunk 1. And big chunk 3. This is I'm just trying to. This is so informal. Don't take this seriously. Don't call these big chunks in your true writing. Call them series parts or something like that. Something actually more formal. B3. It's just names. So with this knowledge, you know that the resistors in big chunk, you just need to add them all together. So that means that you know voltage, you know the resistance. All you're trying to find is the current. So if I use my I is equal to V over R on each of them, I1 would be equal to V over R. This would just be 5 ohms. And this would just be equal to 5 volts. Same story here. Or not really same story here. I2 is equal to volts over R, which if you cross out is just 5 divided by 2 plus 7 ohms. Same, not the same thing, but like it's in series, so you just add them up. Each of these big chunks, you can think of these as series. I'll explain the parts to do that later, but I'm sure James probably. What did James go over then? Okay, so I3 is equal to V over R, and then just what I've done previously, 5 over 8. Now, I'm pretty sure all of you guys have gotten to the point where you pretty much know the answers. I3 is probably equal to like what is this? 0.625 or something like that. Yeah, I'm right. 6.25. This one's like I2 is equal to like 0.9 on repeat. 0.5 on like repeat, and then I1 would be equal to 1 amp. 1. And you can see now that, oh look, the one with the biggest resistance had the least current, and the one of the most least resistant, least ohms, had the most current, while one of the most resistant had the least current, while the one of the least resistant is equal to more current, while more resistance is equal to less current. That's what I tried to say. And you can see That's how the formula is proven here, and how these big chunks, you can see that the total was 9, and you can just see what I've tried to explain. Do you guys get this fast-paced lesson that I pretty much show that all of you guys, do you guys, do you guys get all this? Yeah. So, I'm pretty sure I'm over time, and I'm pretty sure you guys might want to go to that machine because you guys are physics people. So, I'm going to end the meeting here, so see you guys later. Oh, if anything, what? Do you have a question, Rice? Or?
No, thank you.
It's a pleasure. It's a pleasure to teach. Okay, see ya. Bye.